Hello everyone and very good evening. Once again, welcome back to the session. So today we are here to discuss about the classifier, one more classifier, which is very famous for interpretation, and that classifier is decision tree. So last week we are discussing the media analytics, where we have seen different scenarios and we have started understanding the business problem, how media analytics is helping to gain knowledge on customers' feedback, trying to find out insights out of it so that they can take a better decision and better understanding is what we have understood. So, like yesterday, what we were discussing is a KNN algorithm, which is a distance-based algorithm. It is a lazy learner. There is no mathematical equations being learned by the algorithm. It just takes the data, calculates the distances, and it is going to classify whether it is a yes class or a no class, purchased or not purchased. He's what kind of a review it is. It is a positive review or a negative review. He's an introvert or an extrovert. He liked the ad, he did not like the ad. He clicked the ad, he did not click the ad. All these things, you know, relate to classifier. So one such other classifier here we have is decision tree. So what is decision tree? Decision tree is a classifier. It can also be used as a regressor depending upon the output y. So when you know what is y is known to you, you have to opt supervised learning algorithm. So when you have to opt supervised learning algorithm, the supervised algorithm is having regressor and classifier. So the decision tree can be a regressor. If you want to predict y, it can be a classifier if at all you want to predict y, which is a discrete in nature, categorical in nature. Okay, so why you are calling it as a tree? Here, a normal tree, what we have, what we see around us, it is having leaves, right? It also has, as you people know, that it has got some branches. And this is what you have. Like this. Our tree would be ulthana. Our tree would start with a root node, then it will have branches, then you will have leaves. So decision tree is having three nodes, one being root, other being branch, and other being leaves. Okay, this is a tree structure. So how, based on what conditions it is going to be. The output of this tree building is giving you classified rules. The output of a decision tree is a rule. Okay, you might get the number of rules, one rule, second rule. So your aim is to pick up the rules and use it for your business, to make profits, to understand the pattern of the person, to understand, do changes to your advertisements, whether it is a social media, what medium of ads is having maximum showcase to the participants and to all the customers, right? This is what we all know. So when we talk about the classifier rules, these classifiers will give us rules and how it is going to give you the rules. So when you have a root node like this, and it is going to work like divide and rule policy. It will take, if your data set is having features, okay, x1, x2, x3, x4, you have the features and you have the output one. It will start taking one particular node, column as a root node. It will strip the branches like this. It is going to strip the branches. The question is which one it is going to pick up as a root node. This is how it does. There are a few questions to be answered here. The question is, yes, when we have to, which one you would pick as a root node, right? Which one you are going to pick as a root node, and which one will be branch, like how it is going to split, and when it is going to stop. These are nothing but your leaf nodes. So the path what you are getting, the path you have from here to here, here to here, here to here, right? It is called as one root. This is your extrovert or he's an introvert. That is your output category. That's your output category. Okay. Now, what is your aim? You have to choose your root node. Now, how do you choose your root node? Okay. What happens if you check a random input? More number of classification rules are formed, which is not a good thing. Okay, more number of classification rules are going to form and it is nothing for us. So we don't want more number of rules. Less number of rules, more the information. If a person liked it, why did he like? What basis did he like? That is how you are going to do, and you are going to process it and analyze the person's behavior. For an instance now, here we have the data, advertising campaign, Facebook paid ads, Instagram sponsorship. The cost is $100, the cost is $90. Success is 50%, right? They earn 1000 rupees. Failure is 50%, they have earned 200 rupees. Right? That is, output is a success or failure. Failure and success. It keeps stripping the branches till you get your leaf node. Leaf node is your output. Leaf node can be 1 or 0. Okay, it is 1 or 0. We can say that this is a decision tree which can be used in any of the sectors. Now, what we are seeing is the social media marketing sector. So, when we have faced some decision here, we don't know what to do with the rules, whatever you got. So, many important decisions, there are a wide variety of informal methods you can use to visualize the various outcomes. So, we cannot take any risk when it comes to marketing. Suppose if I say my colleague is very much interested or he got attracted to one particular product, right? What if my marketing does not mind the office role, but they haven't considered how it will affect our strategy in the long term? You cannot make a decision properly without introducing some decision making method. Okay, so that's where we are interested in a decision tree. It is, if you observe now, it is a flow chart like structure. Right? It will help you to analyze the various courses of action you might take for any given obstacle or any consequences for each. So these, it will help you to do a comparison, or you can weigh your risk and your reward, and you can map out a course of action to follow. So this is helping you to include more potential actions and outcomes, and you have also reduced the risk for any consequences which were not seen yet. So here, this diagram is helping you to conclude few things, right? So you are deciding whether to advertise your new campaign on Facebook using paid ads, or that will get on YouTube, right? On Facebook and YouTube, that you want to go for paid ad membership or not. So you will assume that both, like Instagram using your influencer sponsorship or Facebook using your paid ads. So we'll assume that both options appeal to your proper demographic, and it has to make sense for your brand. So you want to put your ultimate objective at the top. Advertising campaign is what the decision you are trying to take. So you will need to draw such arrows. Those arrows are nothing but trying to draw a flow chart. So you have only two actions to take: Facebook paid ads or Instagram sponsorships. Your tree might include multiple alternative options depending upon what is your objective, what is your aim. You want to draw branches, you want to strip those branches, many things you can do. So you need to figure out the odds for success versus the odds for failure. You might examine that, here it is very, very small data and time requirements, and you have predicted outcomes. So you will also have to consider many things. So in advertising campaign, there's a 50% chance of success or failure for both your Facebook ad and Insta ad. So if you succeed with the Facebook, your return on investment is around 1000, and if you fail, your risk is losing $200. So Instagram on other hand, 950. So to evaluate the risk versus reward, you need to find out the expected value for both the avenues, right? And you have to take your predicted success and try to find out many other things here. So even though the Facebook is having higher return on investment, Instagram has a higher expected value, means you go with higher expected value data. That is ultimate, you go for Instagram sponsorship only, right? So the combination is here, you have a qualitative data and you have a quantitative data. So one more example here is, here the tree grows if you have multiple variables. When you have more number of variables, right? It's like yes, no, yes, no, yes, no. You strip, you try to build a tree to the maximum extent, maximum length possible. Okay, is the content relevant to the community? Yes or no? If it is no, relevant to an employer, relevant to only a specific part. If yes, you try a personalized idiom. If no, do you have a photo to include? Yes and no, right? Otherwise, all the employees, yes and no. Group email or Slack, direct email or Slack. Does he use a Twitter? Is it an event? Is it a news highlighted? What is that? Post in Slack and newsletter, right? So this is how the tree is going to give you the decisions. The path, what it is going to follow is one rule. This is the path which is going, it is going to follow. It is one rule. This is rule 2. Like that, your aim is to get the minimum rules. But now question is, why did you start with only the content relevant to the community? Why that is your root node and yes and no are your leaf nodes. So this algorithm is called as greedy algorithm. Okay, this algorithm is called as greedy algorithm. This, why it is called as greedy? Because it is a top-down recursive divide and conquer manner, and it is calculating something called as information gain to get the best root node. So we are not doing anything manually, we are getting the best root node. So tree is constructed, attributes are categorical, input data is partitioned recursively based on your selected attributes. List attributes at each node they are selected on the basis of this measure, which is called as information gain. And now the question is, when you are stopping this partition, all the samples for a given node, they belong to same class. Okay, there are no remaining attributes. There's nothing left out for partitioning. There are no samples left. There are no samples left. So let us understand now what it is, how do you calculate this information gain, and the other set of things here. So this is how we have to do. It's like, we have something called as information content. What it is? What is information content? It's nothing but when we are trying to understand anything which we don't know. There's a lot of information underneath it. If I say, I think that we have an example here. Yeah, if I say something about the sun, everyone know more about the sun. There is nothing information available. It is totally new. So there is no information. It is inversely proportional to the probability, and it is equal to 1. If I say there's an earthquake in Hyderabad, so generally we don't see any such situations in Hyderabad. We don't have huge rainfalls. We don't have earthquakes. It's something which has happened out of normal, right? Away from the normal. So there is a lot of information. You have to know why it happened, how it happened, what are the consequences, what led to an earthquake, right? Is it anything is mapping, or is there any chance that it can happen again in future? Lot of information you can grasp from that. That is where you say that there's an earthquake in Hyderabad. So the probability, information content is very, very high. The probability is very, very low. Ulta. Using this, right? Using this, you calculate information content is 1 by A. Okay, so if a probability value, if you do reciprocal, it is very, very high. So what you do is you directly take log of 1 by P of E. Okay, so that 1 by E can also be removed, and you can make it as minus log of P of E. So this is nothing but, you call it as a mean. Mean is nothing but your information content. Okay, what is this expected mean? What is this expected mean? Okay, so what is this now? When we say something which you are trying to calculate in a long run, you call it as expected mean. What is the formula for expected mean? I is equal to 1 to n xi p of xi. Okay, this is called as expected information, which is called as entropy. How do you write entropy? Minus sigma p of I log of p of I. 1 minus entropy is called as purity. It is nothing but we are trying to calculate the error. Right? Using this formula, we will calculate something called as information gain. This is the formula. Now we are not worried now how do you got the formula because I have explained you that. So scenario here is if a person's salary and gender and age is given, okay, assume that he would purchase a product. Okay, we can have multiple inputs also. Okay, given a person's salary, okay, gender, or you can add one more column like you want he clicked or he did not click. Right, you can also add one more column here, right? Whether a person clicked it or not clicked. Okay, multiple inputs you can have. Yes, no. For instance, now we will do it for two only. And we can say no, no, like this. Okay, so this is your binary cross entropy calculation because it is a binary scenario. So how you are calculating this? We want to choose this one as a root node or this one as root node or this one as a root node so that you can guess whether a person would purchase. He has clicked on your ad and he has clicked on your ad and he has checked it and he has purchased it given his other details. Okay, given his other details. You can have a bunch of columns here, not required for us for we're understanding the concept of decision tree. So I would start with, this is nominal data assume. I'll start with this one. What is the best practice or the best thing I can do? The people say that it's an assumption or it's a fact that decision tree, if at all you have any continuous data, you divide them into categorical. You discretize them. So I can discretize this as one and this as other. So if I take salary, if at all I'm trying to do a discretization on top of it, I made into two bins. And anyway, I have yes and no scenario here. And I'm dividing it into two categories. Greater than 100 also you can make. Okay, this is the best classification I can do for this salary column. Then I have predicted value is equal to actual value. Predicted value is equal to actual value. Let us assume these are my actual values. Assume that yes is my predicted value. Actual value, predicted value. Let us take first 10. 10 predicted value is equal to actual value. 10 is equal to predicted value is equal to actual value. Now how you are telling it is equal to 10? You are saying that actual value is yes. Predicted value is also yes. 1. Okay, $1. If he is having 1 comes under this, what is the predicted actual value? Yes, this is equal to. Then 50. Yes, predicted value is also yes. Then this 100, it will come here. Predicted value, actual value. There no. Then 1000 predicted value, actual value are no. So you can observe that there is no mismatch happening. There is no mismatch. So I have done it for output and this is not required for me because this is a nominal data. For this I am doing the entropy calculation. There is no mismatch here when we got this. Okay, now I can also start with age column. I can also do it for click or now click also, but I want to do for age column. So age, split it into 2. What's the best split you can do? Less than or equal to 15, greater than or equal to 15. Not equal to, greater than or equal to 15. First one is 15. It will come here only. Actual value is equal to predicted value. This is yes class. This is no class. This is yes. This is also yes. 10. This is yes. Predicted value. This is also yes. 15. Right? Actual value is yes. Predicted value is also yes. Right? No, 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 no. 15 will come here, but this is no, this is yes. Actual value is no. There is a mismatch, not equal to. 20, it would come here. Actual value is no. Predicted value is also no. One mismatch is there. Maybe this is having maximum information than compared to age. So maybe salary only you should take it as a root node and start making your tree. Start your tree building. Now what you should do using this mismatch or no mismatch, we will calculate something called as information gain. Right? How this information is captured? This is nothing what we are doing, which is called a measure known as entropy. Okay, so information gain you have here is entropy before, entropy after. Entropy after is towards left and towards the right. Towards left and towards right. Right? So entropy before, entropy after. If you add these two and subtract these two, you get something which is called as information gain. It is called as information gain. So we will calculate entropy before first, then entropy after. Entropy before is nothing but minus sigma I is equal to, only two classes are there, P of X of I log to P of X of I minus P of X1 log to P of X1 minus P of X2 log to P of X2. So this is a 3 by 5 log 2 3 by 5 minus 2 by 5 log 2 2 by 5. This you calculate, you get this much. This is for salary. Okay, now I have to calculate it for entropy after. Nothing but entropy left, entropy right. Okay, first if I calculate entropy left less than or equal to 50, this is less than or equal to 50. In this, you have all S classes only. So minus 3 by 3 log 2 3 by 3. There is no class in this 3. So minus 0. Here there are no S classes in this. You have only no class, there are 2. The probability is 2 by 2 log of 2 by 2. There is no S class, you get 0. Right? This is 0. This is 0. But you have to add these two, but multiply it when you want to okay, here and there. You have to multiply it with out of total entries less than or equal to 50. How many entries are there? 3 by 5. Out of all the 5 entries, how many are of less than or greater than 50? 2 by 5. We multiply 3 by 5 into 0 plus 2 by 5 into 0, which is equal to 0. So entropy after is equal to 0. Entropy before, do subtraction. Information gain pertaining to salary is 0.970. Now our decision tree would calculate not for this because this is no variance, it is 0 variance. You can delete it. for this column, and that is decide as your root node, starting with salary, like this, starting with salary. So this is what we have seen here, the salary feature. Okay, this is how decision tree is going to work. So it is a very much greedy algorithm here. Why it is greedy algorithm? Is that it wants lots of information. That's where it starts splitting your data from that, and you try to pick up the input which is having maximum information gain. So all the attributes are important or not is checked using a plot, which is called as a variable importance plot. Right? So that split off, it means you're picking up a right node and it will stop when there is no data left out. It will only stop when there is no data left out. That is nothing but tree will grow to the maximum fullest extent. How much totally you want to do, that totally the tree will grow. So let us understand this in our collab. Taking time here, just a minute. So on daily basis, I want, on daily basis, I want pandas, numpy, matplotlib, right? And I want train, test, split, and seaborn package. So pandas is used for data manipulations, pulling the data, trying to make it preparation, which is easily understood by the algorithm. NumPy, it is used for mathematical operations. Matplotlib for the plots. Seaborn package for advanced visualizations. And train, test, split to check whether your model is overfitting or not. So data here is marketing expense, which is decimal, production expense, continuous, multiplex coverage. How many multiplexes are covered on an average? What is the budget? What is the length of the movie? What is the lead actor rating? What is the actress rating? What is the director rating? Producer rating? Right? Like that, you have bunch of 19 columns here. Okay, there are 19 columns like this. Okay, director rating, producer rating, critic rating. Okay, how many trailers, the trailer is released, how many views are there, 3D available, what is the time taken here, and how many hashtags you have for the Twitter, what kind of a genre it is, and finally, you are checking the average age of the actors who are there in the movie, number of multiplexes it has been used for release, and collections pertaining to that particular index, and check a classifier whether it is winning an Oscar or not, whether it is winning an Oscar or not. This is our business problem, to know which movie, because it is a media analytics. We are trying to find out how many movies are there. There's a chance that they may win Oscars, they may not win the Oscars. So data here we have is 506 rows with 19 columns. Most of all of them are continuous, but here you can see 3D. It's available or not. Genre, that is your 3D available or not journal. Those are your categorical, where you need to convert them into an understandable format, because most of them are numeric, right? So if you do describe function, right, you are going to get the minimum value. It's a box plot output what it gives you. is.na, checking the NA values in your data. Checking your NA values in your data. And see here now, is.na would give you whether it is a true or false. But the sum is going to give you how many NA values are there in a data set. So given these inputs, you can predict whether a movie is, there's a chance that it might win an Oscar. So a histogram, because all are continuous data here, and you can see a kind of skewness for most of them. Here and there you have your only collection is a normally distributed curve, and you have skewness here and here, budget. So almost all the columns are having skewness. Okay. So what is happening now? You are trying to get the outliers also, right? If these outliers are there, right, maybe it might affect my accuracy. So I do the outlier treatment. Okay, to do the outlier treatment, I want a package which is called as feature underscore engine dot outliers import Winsorizer. This Winsorizer is using a capping method which is called as IQR, and there are outliers on the topper side and the bottom side, and I'm doing it for one column at a time, which is the collection column, that being numeric. Okay, after I have done this, you can see that it became a normal data and there is no skewness in that data, right? Then I'll do it for budget column. So Winsorizer is what I have linked. IQR is nothing but you are writing Q1 minus 1.5 into IQR, Q3 plus 1.5 into IQR. Anything less than this, anything greater than that is an outlier, right? So you are saying that I'm using that particular formula here. So Winsorization is a technique where you will take all the values and you suppress them 95th percentile on the upper side. All the values on the lower side, you suppress them to 5 percentile. That is what Winsorization will do, and it will remove the outliers. See, for the trailer views, for all the data we have checked. Okay, so duplicate, data got duplicated. If you have any duplicates here, so sum of the duplicates is equal to 0. And if you observe whether there is a 3D available or not, if you feel that is not important, you can remove. You can remove that 3D is available or not. So if it is available or if it is not available, right, you can take it as an input, but if you want to drop it, a kind of feature engineering you do, I have just given, I took an option, I tried like a trial and error method, I removed it. Okay, I removed that. Now I want to bring all of them to one stake, means one standard. That is, it should be, the range should be 0 and 1. So I've taken genre column and I'm saying that genre map, I'm mapping action as 1, drama as 2, thriller as 3, comedy as 4. Okay, I'm mapping here. and I'm using normalization function here, then you can observe here that genres range, Twitter hashtags, time taken, every other column is having same range, right? So that your algorithm will not pick up few things from one particular column, it will not leave the another column just like that. Then I got to know that 276 are 1, 230 are 0. So out of total, my predictions will go with 1 and 276, 0 is 230. So I can do two ways. I can drop off my start tag Oscar column, okay, and I'll pick up only X, which is my input, and I separately take Y, which is my output. So sklearn dot model underscore selection import train test split, right? And I want decision tree. This is going to do a random split, okay? X test, X train, Y test, Y train, split it with 70-30 ratio, and random underscore state is nothing but it is holding your train and test data so that they don't jump here and there. Train data should hold train data, test data should hold test data. So the model is a decision tree classifier. What I have explained you as a criteria is entropy. Leave about the rest of the things here as of now. Leave about the rest of the things. So what happens here is I build my model and I'm fitting it. Once I fit, this is my tree, it's very enlarged format. I will predict using my X test. Right? I predict using X test. So these are my output. Okay. If I predict on my X train, taking all the input, this is my prediction. Okay. So what it is doing here now, I would like to know the confusion matrix where we have got the confusion matrix like this, actual value and the predicted value. Then you got the accuracy of this model. 53 is only the accuracy. On the same data set, if you have used KNN, you would have got a better accuracy, maybe. Or we have used one more classifier, maybe it is giving you a better accuracy. Right? So in this, now the accuracy of the data is very low, 53 and 57. It's not up to the mark. Model building. That is the conclusion. So what are these now? These are nothing but these are the hyperparameters what you have in your hand as weapons to make your accuracy better. You can work with reaching out for the less false negative values or false positive values. You want to improve the accuracy of the model, right? All you want to do this, you have few things which you can play around and do the best split happening according to your choice. So maximum depth, maximum features, minimum samples underscore leaf, CCP underscore alpha. These are the widely used hyperparameters for decision tree because these help you to generally there is a tag that decision tree would overfit. Because I have dropped the 3D column, maybe the accuracy is not good. That is important. 3D means it is very important for winning an Oscar is a chance. Okay. So now the point here is if at all our model is overfitting, now we don't fit. We don't have that problem here for this. It is underfitting. So I have deleted this. You need not do feature scaling for decision tree. This is not required. 3D is important maybe. right? These are the parameters which I did not give properly. Maybe because of that also it is underfitting. Reasons could be anything, but our model is underfitting. Maybe this class you tune it, you do changes to this and you check for the accuracy. If it is coming fine, you are fitting it properly, then you can stop. Otherwise, you can go and build another classifier on top of the same data. It's like experiment. So if your model overfits, if your tree is like, what is overfitting? When your model is learning worst on trained data and it is very good on trained data, worst on test data, right? Worst on test data, very good on training data, then your model is overfitting. It means that you are learning at home very, very nicely, properly, but in exam you're writing all mistakes. When the test comes into picture, you are writing all the mistakes. So your marks are coming down. When you write at home, you are getting good marks. That is called as overfitting. So it is not, when a new data comes into picture, your model is not able to generalize the results properly. It's a very, very worst model building. For that, you have a regularization technique. Now, what are these? Maximum depth, maximum features, minimum samples underscore leaf, or maximum splitter or criteria. These are the things which you have in your hands. You can change them and you can build the model. So that you are giving again and again training, means it is even learning the noise in your data. If there's a noise available, that is also being learned here. Right? So that technique here, you call it as a pruning technique. Now what I have done is, I have done pre-pruning. I don't know whether the model is overfitting or not. But I pruned it before only, without checking whether it is overfitting or not. When I pruned it, to our bad luck, it underfitted. So what do you understand? You have to allow the tree to grow to the fullest extent. Then you have to take a call and reduce it, change the hyperparameters. Even before you don't think of anything and you just do pruning, it is called as a pre-pruning. It might not give you good results. Post-pruning is far, far better than pre-pruning. So if someone asks you which one is a good technique, pruning the tree is a technique which is called as a regularization technique, and that is going to help to get rid of this overfitting problem. It's a regularization technique, we can say totally. It's a regularization technique here. So pruning is divided into pre and post. This is what we have done here, but without giving anything, removing all this. If you run the model, you see overfitting, then you come and do pruning, which is called as a post pruning technique. Post pruning technique. So the extension of this is random forest classifiers. If you think that this model is not working, you can build one more model on the same data, one more model on the same data, one more model on the same data, like this. Multiple decision trees are there in your random forest. So this is using decision tree and it is building multiple models on the same data, which is nothing but we call it as doing ensemble modeling. Nothing but doing the ensemble modeling. So two things which are not up to the mark here are scaling is done, 3D is available. Maybe we need to cross check it. So maximum depth means, if I say maximum depth is equal to 3, 1, 2, 3, 3 depths. This is not there, one line. Okay. This is called as depth 0, depth 1, depth 2. Okay. Depth 0, depth 1, and depth 2. 3 depths. Means it will stop. Will not grow more than that. Okay. So there's something called as ECP underscore alpha. This is one of the parameter. Very, very least value if you give, it will do the best pruning to solve your overfitting problem. To solve your overfitting problem. So, how do you choose that? Is you can do it using, like, every time now you cannot give a number, check it, check the accuracy, feel happy. You have to go back, change that value, come here, check it, again feel happy. So this process continues. Your model will learn the patterns even for your test data also. You're revolving around your train data, test data, train data, test data. Right? So what happens at time? Your double split should be changed to triple split, which is called as a train, validation, and test. Right? Here accuracy is not important. Here we say that we want confusion matrix, we want a crosstab, we want false negatives, and we want false positives. Absolutely wrong model building can also happen here, because not all the algorithms would work as the best for every data set. Sometimes classifiers work, sometimes regressors work, sometimes classifiers, in that you have different variants which would help you to get the very, very good results. So decision tree classifier need not, it doesn't take inputs directly. You have to take discretization. It works on a criteria called as entropy, which is nothing but impure form of your data. It is also called as error. It is called as what you call it, as a cost function or a loss function, right? And you are calculating root node based on the information gain. So any classifier or any data where you have binary class scenario, decision tree holds good. Okay, so this is our decision tree. This is how we will get, as I told you, this is how you are going to strip. Now, how do you choose this? Based on the highest information gain. When you will stop, yes or no, yes and no, yes and no. Every path you take from root node to the leaf node, it is one rule. 1, 2, this is one rule, this is one rule. Right? This is a path what you are following. So that path is one rule. If at all you're getting more rules, it is not acceptable. Because if someone is clicking and someone is purchasing, you just call back him and you will again give him more details about the product. Like you want to definitely want him to purchase the product. Right? The customer gets irritated here. So what is the chance that yes, he has clicked on it? The other details. Now, if a person has clicked on the ad and whose salary is $500, is whose age, or whether he's a male or a female, he would purchase or not purchase. If he's not purchasing, what will happen? You change your strategy. You say that there is an off on Friday evening at 7 o'clock. There's an off on Monday morning. You can purchase it. You give a personalized messages here so that the customer would be very, very happy. He'll be loyal to you for most of the times. Right? He will be loyal to you. This is how in media, right? Whether it is ad agency, or to know whether it is a movie related issue, whether any type of media, or whether it is your tweet, or whether it is your review, right? Any data classifier is required. Mostly if it is a text data, again you need a lot of processing. So here you have your numeric data. It is very much easy to do this. So this is our decision tree. This is your DJ by D. So how many categories you are doing? You are doing binarization or you are doing discretization. There is more than 2 categories. That you are D by D. For our data, we have done 5 are there, out of which 3 belong to you less than or equal to 50. 5 are there, out of which 2 belong to greater than 50. That is 3 by 5. And this is 2 by 5 into information gain of that particular entropy of that particular column. This is entropy before info D, entropy after subtraction. That's what I explained you in the Excel sheet. So thank you so much for joining in. Thank you. So tomorrow we will see with a different machine learning algorithm, with a different use case. Thank you.